Hello, this is a note about accuracy of chart plotting, comparing, measuring the heading or the course line on a paper chart versus electronic chart. It's a kind of a detail. It's come up in our online class discussion, and it has to do with working a problem from this book. This is our navigation workbook that we use in our course. It's also available online as a purchase. And then we're looking at chapter 2, and then this is just a straightforward problem right here. What is the distance and true bearing from buoy 2 at New Dungeness Spit? And that workbook is all about chart 18465TR, the training chart. So we go from buoy 2 at New Dungeness Spit to buoy 4 at Port Angeles. So that's the exercise we want to do. And we want to do it with both paper and with eCharts because it looks like it looks like you could maybe get two different answers. You really should not get two different answers. So we want to confirm that to be sure that everything's working like it's supposed to do. Okay, so here's the one. Here's the buoy 2, and let's home in on it. There it is right there. And then I've just made a one-leg route that go over here to this. Oh, that guy's a little bit off. Well, now that's obviously not going to matter. Now with OpenCPN, if I want to move this, I have to right-click and I have to look at the properties. And once the properties are showing, I can move it. And then if I want to get fussy, put it square in the middle. Okay, so that's that. Then I can just put the route on here. And it says it is on here, it says it's a 263. Okay, 263. Yeah, 263. Now, that we have to keep in mind is rounded off. So let's look at this another way. So in other words, what's this program does not show decimals, and a lot of eChart programs don't. Some do, others don't. This one doesn't. That means if we want to try to get a decimal on this, we're going to have to do a little bit of tricks. So let's do this. Let's totally start over, because you can't unlock this and then do it again and read active bearings from it. Not in OpenCPN. You have to. You can do that very nicely at first, but not once you've planted it there. So let's delete that guy. Yes, delete it. And let's start again. At this point, we're right. So I'm going to click the route tool, and I'm going to go right bang in the center of this guy. That looks good. Now I'm going to use the mouse, and I'm rolling out on the mouse to get over here. And now I'm just pushing it on the page to get it kind of where we want to go in the center here. Now I'm going to roll the mouse the other way. Okay, now I'm going to zoom in. Now we've got this. Now you see, read the bearing there. See, it's 262. There's 263. You see, there's 263. And I keep going up here, and it still reaches 263. And there's 264 right there. You see, that's 264 right there. And if I come back down and come up, here's 262. Here's 263.0 right here. So this would be something like 260. Yeah, it's too bad we have to do this and not show the decimals. But anyway, that's the way it is with this program. That's 263.0 right there. And then up here is 263.4 right there. So this actually looks like it's 263. If I measure it from from this eChart, I'm going to come down here and drop this. And if I drop it there and then hit the escape key and ask what it says it's 263. If I give this a name, let me give this a name called a test leg. That's the name of that, okay. And now go in here. Let's see if it does anything more precise on routes. Test leg. Oh wait, test leg is here, and show the properties. Do we get any decimals over here? 263. It doesn't give us decimals. Now we know that's not right. That's not 263. This program is giving us 263.5. We'd have to say 263.5. Now, this is indeed the training chart, right? That's a training chart. Well, let me come back in. I just want to be sure that. Let me roll this out. See if we really did the training. Oh no, that's not the training chart. That's the official navigation chart. That's the most recent one. Let's go over here. Now I'm on the let's go back here. Now I'm on the training chart. Nope, not yet. 18471. Well, here you can put this over here. What's this? Eastern 1 to Fuca. That's a training region. 18. Where's the chart now? Oh, this is the training chart. Okay, let me look at the bottom corner here. 18465 TR. Now, do these things matter? I don't know. That's what we're trying to find out. That's a very slight shift. Obviously, all of our problems are worked with the training chart. So let me do this again. This is all the sort of things we're trying to sort out because there was an observation that something was not consistent. So we have to look at all the ideals here. So I'm going to go to Properties. And then as soon as the Properties button is showing, I can drag this guy. Well, excuse me. It can't be the properties of the route. It has to be right-click. It has to be the properties of the buoy. I mean, of the mark. And once that mark is showing, now there, I'm bang on the money on that guy right there. No doubt about it. And now let me come to the other one. And again, this is now the official, whatever. It's the training chart. So you see, those were a hair off, but not I don't think enough to go make a difference. But let me just move that guy. He's right square in the middle now. Okay. So now that's certainly going to say 263, is it? Yeah, that's still 263. But now we have to do our exercise again. The whole function here is to try to figure very accurate bearings. And so I'm going to delete this. I'm going to delete that. Okay, yes. And now I'm going to go in here and start a route right there. Start the route. Okay, now come out here. Okay, come out here to the buoy. Here's the buoy we care about right here. Now I made a waypoint here. Shoot. Okay. When you do that, there's no way around it. Because you can't. You see, if you can't do anything here. That was a mistake. You do that, you got to start over again. Okay. So I don't know. Some people would yell and scream and say I should edit this out of here. But are you sure you want to delete this route? Yes. But I'm not sure that's valuable. It's sometimes it's better to see what you're up against when you're trying to do some of this stuff. So let me start again. I'll start here. Go right square in the middle of this guy. Right there. That's pretty close. Go back out. I'm going to do the same trick we did before with sweeping around to see what the decimal is. Now we have other ways to do this, and I'm going to show you that in the end here in a minute. We've got the paper solution, so I know what the paper says. I know what the paper chart says, and we have a video that shows that. But now let's start here. Okay, so this is now 262. There's 263. Oh, and there's 264. Look at that. On this chart, it's closer to 264. You see, there's 264, and that's just like that distance right there. But if you come down here, 263, 0 is way down here. So this is really something like we'd have to say using the training chart, which is our job in this course. We use a training chart. If you wanted to claim what's the most accurate bearing to this, you're going to have to say something like 263, 0.7 maybe. 263.7 or 0.8. 263.7 or 0.8. Let me write that down. 263.7, 0.8. I mean, we could screw around and decide which is right, but anyway, that's close enough. All right, so that's the answer. 263.7 or 0.8 with this eChart. Now, the other thing we can do is keep in mind that these are the raster charts, which is a picture of the paper chart that then is rasterized and made into a chart. Now, we can assume that they're done correctly, but that's not always guaranteed because it's a different step. In a minute, we can go down and do this with the ENC, the electronic chart. That's more accurate. It's one of the virtues, another sort of hidden, very subtle virtue of the ENC charts is everything is more accurate. It's digital. But let's check something first. Let's just look at a route here to be sure that this thing is oriented properly. So, whoops, escape. Or I can just use the M key for this. Let me use the M key and just go right straight like from here. I'll just go from here. I just want to be sure that if I go up this line, it's 0. Okay. All right, so that's there. And that's 0, 0. Now let me go a little bit to the left. That's 359. That's pretty close. See, there's 0, 0, and then there is 01, and here is 359. Well, it's not exactly right. Not exactly right. It's actually, okay, it's pretty close. It's like 0. Yeah, it's pretty close. Oh, no, we want 0, 0. We don't want any decimal off of it. We want it right where it changes. Literally right where it changes, and that's very good. Okay, so that direction seems to be pretty good. We've checked it that way. Now we can come down here and check it the other way, and this should be like 90, right? If we go this direction. Okay, I started a new point. Let me just delete that. We can use, for this, you can use the M key, which is just measuring a distance. So you come along here, and you see that's 90. There's 89, just going to 90. So this chart is actually good. It's oriented properly. So we say that bearing, according to this electronic chart, is 263.7 or 263.8, something like that. And we're done with that. Then the next, okay, then let's just double check. We go to now this chart. Now, I guess we don't have to do this again because we've got this on here. This is now the digital location of this buoy based on the latitude and longitude in a digital format. So you see there's a little discrepancy here. If I put the M key on from here to here, it's not much. It's like 100 meters, 103 meters, but it is off a little bit. So let's grab this guy and look at oh, no, can't do the properties of the route. You have to do the properties of the buoy. Okay, properties. Now, let's grab him and put him right on the buoy. Okay, that's good. Okay, now we go to the other buoy. This is going to say 263 anyway, so it doesn't matter. Let's just see where they're positioned. And this one seems to be very close. I'll just right click and move it a hair. Right there. Okay, done. Okay. So this is obviously going to say 263. Right. So that's nothing dramatic there. But then let's now delete this. Delete. And do this trick again. Yes, delete it. And we start a route from here. We zoom in, get on the right spot. Whoops. Escape. Start a route right here. And then go over to the buoy we want, which is there. Notice something you see about ENC charts is you scroll in, there's something called SCA min. It's a minimum scale that a buoy chose. And that buoy has a SCA min of something like, I don't know what it is, but you see that's not even there. In other words, you have to get the scale so small before it even shows up. That's a property of the ENC charts, which we'll discuss somewhere later in the course. Okay, so here's the buoy, and that's the 263. Now let's come back down and see where does it start. 263 is way down here. There's 263. Now let me come up. That's about the same. It leans a little bit towards the smaller one. That's 263, and there's that distance. 264. Yeah, I would say this is favoring the 263.7. Well, anyway, that's that. So those two confirmed. There's nothing magic in the charts. That's what that true bearing is. Now, we have another way to do this. We can just outright compute it and not rely on any tools. If we're really doubting our tools, then you can go in here on an ENC chart. Not very nice to do this if you go in here, if you go to this chart and you go to this buoy, now the computer is going to tell you what it thinks. See down here, read down here in the bottom, the computer is going to tell you what it thinks the latitude and longitude is at the cursor, but that's believing a whole bunch of things. That's believing this program's all working properly. But if you come down here and you go on here and then you right click and say query the object, now this is the official Coast Guard truth of what that buoy is. And there's that latitude and longitude. So then what we can do is go back to the other buoy and get the same latitude and longitude and then compute them and compute the bearing between the two to a very high precision. And I'm going to stop this video here. This will have like 3 sections to it. It'll have the chart with a paper chart. It'll have this this eChart stuff, and then we're going to have the computation based on the things I get here. And I'll do that and prepare that video and do it next. Okay, so here is now the computation. I'll show you where we get this in a minute. There's lots of places, but we have the page starpath.com/calc, and I'll show you that in a minute. But you see, we put in here, this is actually an ellipsoidal calculation. It doesn't make, for this short a distance, it doesn't make any difference. You could use Mercator, a rhumb line, or Mercator, or a great circle, or the ellipsoid like I've done here. They all give the same answer roughly. Essentially, with the level we're talking about. So this is what I get from cursor picking the ENC chart for the location of the buoy number 2, and here's the same thing for buoy 4. Then I take this latitude and longitude up here and put it into here, latitude, longitude here for number 2. And then push the button, and I chose WGS 84. This is a subtle program. It actually takes into account the shape of the Earth. And so, but the chart we're using is indeed WGS 84. Okay, and what do we get? The course is 263.65. Now that's interesting because we did conclude by looking at the ENC. In other words, we looked at the RNC and could not decide if it was 263.7 or 263.8. And then again, and we didn't analyze that in very detail. That's all done by eyeball. Then we went to the ENC chart and we could tell definitely it was a little bit closer. And we said, and the conclusion I made was it was 263.7. Now, let's look at the truth here. The truth is it's 263.54. So that's the answer. That's the honest to goodness answer if we had good tools to measure it and everything was plotted right. 263.65, and our 263.7 is just fine. And then 83. Then the distance. No, wait. What's the distance? 15.3. Well, we haven't even been worrying about the distance. That's not been the issue. Okay, so that's that. Now then, the eChart. Then the answer. Oh, okay. So I'll put this. Let's see. Where will I put this? The paper, okay, I'm going to then just tack on the paper chart at the end, and then maybe the paper chart is a separate little movie, and then I'll combine them and make a comment at the end. This is a check on accurate plotting from an exercise in our workbook, I believe, and we're drawing a line from this buoy R2, and note that that's going right straight through R2 buoy. And then this line comes over to go through this buoy, that's R4. And you see it's going right straight through. That was drawn with this big ruler here. Okay, so that's that. The question is we're getting two different values, one from the paper chart and one from the electronic chart according to one set of measurements, and we're trying to track down if that's a real discrepancy or if we're making a mistake somewhere or there's something defective. Now the next part is we take this thing, let's see if I can do this without disturbing it. Okay, so now we look here, see that that's lined up right on that line. And it's also, let's see, right on this line. You can't see it. It's right on top of the meridian. Okay, then we come over here, and you see that that is 6. It's actually 6.0. And notice we could read half a degree here. You know, we could easily read within half a degree. You know, this happens to be right on 6 degrees below 270. So that would make it 264. So the answer here is 264 measured from this paper chart. Hello, okay, so we're now in the final section here in the summary. So here's a summary, I just wrote it out so I don't forget things. So we did the paper chart, and we did it as carefully as you can. Those triangles are considered the most accurate way. We got 264.0, not 0.3 or anything 0.5, it was right on the money. And we could see 0.5 very easily. Anyway, this was done, but that measurement, which is in the past video here, that was actually done the very first thing. It's the first thing I did. I did not know the answer from the eCharts. So that was that. Then we did the RNC eCharts, and we had the problem in the sense that the program did not let it read decimals. So we had to kind of interpolate, and we got something 263.7 or 0.8, not clear. Then switching to the ENC, which are more accurate because the buoy positions are digitally placed at the right latitude and longitude, and we don't rely on any printing at all. Then we got 263.7. Again, though, we had to kind of interpolate this, but it was clearly closer to the 7 than the 8. Like that. So then the next step was we went and read from the ENC. We can right-click the object. That's called a cursor pick. That's the way you read these charts. And then you read all the details about the object. And we read the lat long very precisely from those. And then we computed the distance and the distance and the bearing between the two, and we see the exact value is 263.65. So that confirms that 263.7 is probably right. And so the manual paper solution was frankly off by 0.3. That's all I can say. And that's about as good as you can do on the paper charts. If you just grab a pair of parallel rulers and you move them around, it's a lot harder to be that accurate even with the parallel rulers. But the triangles are considered the most accurate way to plot. Okay, quick question then. What distance on the chart does this 0.3 correspond to at that distance? See, that obviously depends on the distance. 0.3 degrees, from here to Nevada, that's going to be a lot. But, so how long was that on the chart? And I don't have the chart in front of me to measure it, but it's real easy to compute that. And I thought it might be interesting to illustrate some of the things that we know. In other words, we know things that we may not realize we know ahead of time here without exercise like this. That's why these exercises are often useful. Okay, the distance between the 2 points was 15.3 nautical miles. We measured that and we calculated that and everything. And then the scale on the chart was a 1 to 80,000. Now, the 1 to 80,000 on a scale means that 1 inch on the chart, put it this way, 1 inch on the chart is 80,000 inches on the land. Or we can go the other way. And so we can say the length of the line on the chart is 15.3 nautical miles, and each mile is something like 60, 78 feet, something like that, 6,000 feet, something. And then each foot is 12 inches, and then that's the total number of inches of 15.3 miles. And then we divide that by 80,000 to see what the distance on the chart was, and that's 13.8 inches. Okay, so the question is, we have a distance at 13.8 inches, and then we swing a little teeny angle there, 0.3 degrees. And how much does that distance move? And that's indicated by the D there. So we got 13.8 inches here. The angle here is 0.3, and what's this D? And now this is trigonometry. You can look this up, or but this is the formula that you would use. This is a formula you would use for the definition of the sine of an angle. And so this little d is equal to the 13.8 times the sine of that angle. And that's 0.07 inches, which you convert that, every inch is 25.4 millimeters, precisely and exactly. That's not an approximation. That is precise, 25.4. And then times 7, and you get that. So that's, now, and that is, if you look back, or if you have one of these pair of triangles yourself, you'll see that that's all pretty consistent with the actual spacing that you could see on the 1 degree spacing. The 1 degree spacing on those protractors, the navigation plotting triangles, which are about maybe 6 inches radius, and so forth. So, so that's our conclusion. That's our sort of little look at plotting. In round numbers, the paper chart and the eChart should give the identical values. Here we find that they actually differ by about, what's the final answer here? By 0.3 inches, 0.3 degrees, which may be a little bit larger than I would have guessed. But anyway, that's what it is. Okay, that's the end of that rather long answer to a question that came up in class.